Oh, hi everyone. We are Group 6. This is Ruby. Our other teammates are Jiahui, Tianxing, Xinyao, and Yunxi. Today we are going to show you our data analysis results and the same things you need to know about Good One. So our content mainly covers 7 parts: statistical analysis, exploratory data analysis, clustering, association rule mining, network analysis, predictive modules, and conclusions. So first, let me introduce some background information. As we all know, wine is a very popular alcohol drink made from grapes. It has been produced for thousands of years. Basically, wine has 5 variants: red wine, white wine, rose wine, fruit wine, and honey wine. Since wine has such a long history and so many variants, wine experts set a set of complex standards to do the wine classification work. Usually, there are 4 stages in a wine tasting: appearance in glass, the aroma of a wine in mouth, sensations, finish after taste. Also, experts need to check the complexity and character, potential and possible faults of a wine. Sounds very difficult, right? Well, actually, it is. Therefore, we want to explore which features of one will influence the quality of one and how will they influence through our analysis. Now let's welcome to our tour and found a good one.
Hi, I'll introduce the data statistical analysis. After cleaning data was combining different data sets, removing columns, missing and incorrect values, setting appropriate scales for data and deleting outliers, converting all data into a good format, and getting the year information from the title and API. The new data sets shown here. For dealing numerical data with the categorical methods, numerical columns are also bound with different groups. The below one shows the completed data set after binding. As the beginning of the data statistical analysis, here shows the overview of the 10 variables for analysis below. Variation here shows the points are very stable. For categorical data, mode is very important. For further information of distribution of each factor, the relation plots between every 2 factors, the color for different province, the graph shows a clear output. There is a positive correlation between the points and the price, which will be proved after. On the opposite, AQI shows a negative correlation with the price. For other factors, the correlation is not very clear now. Visualization of box plots depending on binding groups can give an intuitive vision of the distribution for each factor. Also, the interaction relationship can also be shown by box plots for 2 factors. The plots on the upper right corner shows that the points of the latitude groups are relatively stable, while the price bands seem to have a large change for different groups, and hardly correlation between the latitude and price can be found here. To know clearly whether the groupings would affect the change of the average points, a ANOVA test is a good choice. For each p-value is less than 0.05. If we set the confidence interval level at the alpha equals to 0.05, the null hypothesis can be rejected, which means that for each factor, their means in different groups are not the same. Moreover, correlation test table with the points help to determine the factor that would affect the points. The correlation test for specific pairs here shows that each factor seems to be independent from the other. Regarding the relationship between the pairs, price shows the strong correlation with points. From previous ANOVA tests, it shows that each group means are different. The hypothesis test of 2 sample t-tests here did the comparison for each 2 groups in one specific factor and gave the decision of whether to reject the null hypothesis. The main difference and the confidential interval. The clear table offered more details. Next, welcome Jiahui to introduce the exploratory data analysis.
Thanks, Yunxi. This is Jiahui. Now I will introduce something about the visualization. We make some visualization of explanatory data analysis. The visualizations are divided into two parts. The visualization of the United States data and of the worldwide data. Each part focuses on different variables. For example, the graph on the top shows the word cloud of wine description. There are many different words used in the description, such as aromas, wine, flavor. Now let's look at the graph on the left. This graph shows the correlation between wine points and yield. We can find that only wine produced after 2003 get points over 97.5. Finally, let's look at the graph on the right. This graph shows the correlation between wine points and AQI. With this graph, we can conclude that only places with high AQI can have wine with high points, which is over 95. Next, I will talk about the clustering. In the cluster analysis, we choose three attributes that may play an important role in the wine quality: wine price, AQI, and the produced year of wine. Well, we use K-means method, word method, and the DB scan method to do the analysis, and set the cluster number as 2, 3, and 6. The graphs on the PowerPoint shows the PCA plot of the cluster by each method respectively. After comparing the silhouette coefficient, we find that the DB scan has the best clustering performance with the wine dataset. Next, Tianxing would talk about the ARM and the next network for us.
Thank you, Jiahui. Subtle associations between wine quality and other factors can be visualized by a method of association rule. In order to apply association rule mining without confusion caused by numbers, the dataset is organized and bin in quantitative columns by the following ways. Top 10 support, we will talk about the tables later. Top 10 confidence, and top 10 lift. The network includes data of top 10 support and top 10 confidence. Note that the green nodes are factors in the dataset and the yellow nodes are selected combinations. We can see that under 89 points over 200,000 population and year over 2,000 are most bonded together, which suggested that wine produced after 2000 from large city is probably not going to be very good. Points under 89 appears more, which also tells the story that bad wine may be easier to define than a good wine from aspects such as price and location. Network analysis is applied locally and globally to visually show the subtle relationships between each factors influencing wine quality. Each node includes the individual information about wine, and edge basically connects wine from the same stage of production. While the edge shows that the connected nodes are in the same price range, and transparency of each node tells its degree, and it's obvious that most wine are made in one state, which is California. The size of the node determines the relative quality of wine. Also, blue color shows a better air quality of city of production, and yellow means that the wine quality is not so good. The big picture of this network tells us that wines are mainly produced from some states, and among these states, California is the most productive wine. Yet, productivity does not decide the quality of wine because almost transparent nodes, meaning that they are from states with less wine produced, can be good or bad according to the size of nodes. Perfect IL quality, which means AQI less than 25, seems to lead to extreme quality of wines, like very good or very bad according to a node size. Let's go to a conclusion.
Thanks, Tenzing. I'm going to talk about the predictive models. Next slide. We try to see what factors might influence points. So first, we try to fit a linear regression model to it, and we take the price and AQI as the independent variable and points at the one we want to predict. And you can see from the results that the model doesn't do very well, and R square is only 0.1988. Next slide. Then we try to take one more variable in it, and now the y is points and the s is price years and AQI. We could see that the R square improved a little, and it is 0.24. Last slide. And then we try to use the SVM regression. And here is a graph of a 2D plot of the SVM prediction. The black scatter is the true Y, and the color one is the predicted Y of each method. So I tried free kernels, which is the linear, poly, and RBF to it. And you can see the results that the RBF performs better, but it also only had a R square of 0.53. Last slide. And then we could see that when we view the points as a continuous variable, um, all the model doesn't do it well. And then we realized that it may be more meaningful to tell the customer whether the Y is of low or high quality. So we bin the Y points into low quality, medium quality, and high quality, and took the stem S into the classification model. Last slide. And then we first see the results of the decision trees. So here is a graph of a visualization of the decision trees model, and the accuracy score improved very much. It is 0.51 now. Last slide. And here is the result of the random forest. It is also about 0.4 50. Last slide. And it goes to the KNN. And here, the left is also the confusion meters, and the right is the free class classification. You could see that it's a little bit massive, and the accuracy score is a little bit lower than it is 0.4210. Last slide. And here is the result of the libraries. It also had the like the accuracy score is sort of like the one that a random forest and decision trees which give us, and it's around 0.5. Last slide. And then we go to the SVM, and we try linear SVM and RBF SVM. And we could see that the linear one gives the best performance of all the classification models. It reached 0.5438. So let's go to the conclusion.
Oh, hi. Well, according to our analysis, we can get several conclusions. First, the price, origin, latitude, and air quality will influence the 1 points. So price is positively related to points generally. And in worldwide, one that come from England can always get high grades. And in the US, ones that come from California and Oregon get higher points. And also in the US, ones come from low altitude. To be specific, is from 29 to 30 to 33 get lower points. Because the lower AQI means better air quality, so the higher AQI of product place will lead to a better wine quality. And for the product description, flavor and plant types are the flavor, aromas, and plant types are the three most important factors for one product description. So sellers are supposed to give more detailed information to the three features. Also, the wine made by plum grapes might be more popular. So I think that's all we have today. We also built a website to show our analysis. So if you are interested in more details, welcome to our website. And thanks for listening.
Thank you. Thank you.